inlet here. Because this is the hot gas combustion from the XMC, you can see. But in this case, we assume the hot gas temperature and also velocity move to the annulling furnace. And then we have the two outlets here at the top of the furnace. The furnace have the dimension with the range here. The long is the 10 diameter, and this is the 3D view, and this is front view. And the furnace height is the 3.5 meter, and furnace width is 4 meter, and velocity inlet port around 0.35 meter, and the some pi range around 0.5 and 0.5. You can see here. And this is also the parameter, the table of parameter and value. And let's here, we see more clearly described. This is the raw and column for the steel pipe with the 5 and 5 here, 5 and 5 column. And then I will describe the modified model. It's also just similar the basic model, but just we just modify the inlet port line. The previously this is directly from the inlet to impinging to the steel pipe, but in the modified model we get the elbow inlet here. We can see here, and then this also, and this is 3D view, and this is top view, and then we can get the, you can see the flow, hot air can make the swirl flow, this recirculation inside the furnace, and then it can enhance the much more the uniform flow inside. And then this is the apple. We select the also the angle from the horizontal is the 30 degrees. And then we move to the chapter 3 for the mathematical model and the boundary condition. And this simulation following the governing equation first for the continuity equation, because this is also the tension here, and the momentum equation, energy equation, and the 2k epsilon, the standard k epsilon here in this, with the model constant something in for the standard k epsilon. We can see like this. And before for the boundary condition and method, in this case, the velocity inlet, the author assumed for the range velocity inlet from 0.1 to 1 meter per second. The temperature inlet at the 1000 Kelvin, it means that 723 degrees Celsius, and also the pressure outlet at 0 Pascal for the just outlet, the ambient air. The turbulent model, we select the standard K epsilon, and the annulling time, 2005 seconds, is around 5.5 hours or something. And then we move to the chapter 4 for the reserve and discussion. And first of all, for the flow field distribution inside the basic model, and this is the 3D view. And we can see here the flow inlet move to inside the furnace, and this directly to impinging to the bundle of steel pipe. And you can see it's really messy inside the furnace. It's not uniform. And then more clearly we can look at for the top view and side view like this. It's impinging directly to the bundle of steel pipe. In this zone and this zone similar, and this for the side view also we can look at it non-uniform like this. And then we move to the temperature distribution inside the basic model. Here we can look at the hot air temperature impinging to the steel pipe arranged inside the furnace like this. This is the cut plane inside. And then this is for the 3D view. You can see here, we can look at in this area, the temperature is much more higher than the other. You can see in this, so the temperature different around 2.4 degrees Celsius. We can see here. So that's why it's not good for the steel annulling process. And then we move to for the modified model, and this is the side view and the bottom view. You can see by using the apple inlet here, the flow will bring to the bottom and make the big swirl inside the furnace. And here, and this is the bottom view. You can see, and 1 and 2, and make the swirl like this. We can much more uniform, and then we can comparing with the public paper by the Han et al. They also make the annulling furnace, but they use the fan at the top of the furnace, and then they can get more uniform inside. We can see here, they got the result, the flow being from the top to the bottom, and then it's recirculation like this, and then they can get the more uniform by using the fan. But in the recent study, we can reduce the electrical energy consumption, but we can still achieve the uniform flow inside the annulling furnace by using the apple inlet here. You can see it's much more uniform. And then we move to the temperature distribution between the modified model. This is the top view, and this is the cut plane AA here. And then we can see the temperature for flow field. This much more for the steel pipe also, and this also more uniform. And this is slide show the steel temperature distribution between the modified model. As you can see, by using the apple inlet, we can reduce the temperature difference of the bundle of steel pipe. You can see the density temperature difference around 13 degrees, but from the last one around 55.4 degrees. So it's much more better than the basic model. And then we can also study the effect of the horizontal and the vertical steel spacing on the steel temperature difference in among of the steel pipe. For example, in this case, the bundle of the steel pipe here, XX is in the horizontal spacing, and the SV is in the vertical spacing in this. And then this figure shows the temperature difference is the function of the horizontal spacing. As we can see, for when we increase the horizontal spacing, we can reduce the temperature difference. And then also for the vertical, the temperature difference is a function of the vertical spacing. It's also similar the chain with the horizontal spacing, because we can increase. This is because that when we increase the horizontal spacing or vertical spacing, it means the more spacing between the steel pipe each other, for example, and then it will reduce the temperature difference. But it can get we cannot get much more the bundle of steel pipe number amount. So that's why, because it not, even though it can reduce, but between 13 and 10 or 9 is not so much, and then we can keep this the amount of the steel pipe, and then we can just enhance the more amount, steel amount. And it's also studied the effect of the Reynolds number on the steel temperature difference among the steel pipe. And this here, if we can see when we increase the Reynolds number at the inlet, and then it also increase the temperature difference, because if we increase the Reynolds number at the inlet, it means we increase the high velocity, and we can reduce the annulling process time. But this expense that we can increase the temperature difference. So that's why it depends on the we can select which one we effective, and then we can select the Reynolds number corresponding like this. And then we move to the tension simulation of the steel pipe under temperature during the annulling process. And this figure shows the temperature is a function of the time. You can see from at the initial temperature and here, and then we can increase when during on the steel annulling process around 20,000. It means around 5.5 hours. We can nearly approach the steady state around 350 degrees Celsius. You can see here. And this figure shows much more clearly from the beginning to the end of the steel temperature. For example, from around 10 minutes, 605 seconds, around 10 minutes, we can see the steel pipe temperature around, it's just not changed so much, just at the beginning, the temperature at the beginning here, but around 10,800 seconds, the temperature is much more increased. It's around 280 degrees Celsius, and at the finally, it increased around 351 degrees Celsius. Yeah. And then the author also performed the total deformation of the steel pipe during the annulling process. And this is of course because during the annulling process, the steel pipe will be deformation if you extend from, for example, in this case, we make the fix in this side, and then we got the free this side, because we need to have the constraint from in this, and then we consider the total deformation with the steel pipe will extend here like this for the first one for the 10 minutes, 600 seconds, and the 10,800 seconds. We will increase, and we can see here it can increase, and then like, and the last one is really the red color like something. But at the final of the process, so the total deformation around 0.043 meter. It means around 43 millimeter, around 4 centimeter. It's not much. Yeah. For the clearly to describe this one, so we show the video clip here. We can show the video clip here. You can see here. We fix first on we fix this side, and then we get the free design, and then we can look at when the time increase here, and then the steel pipe will extend in this free. You can see here and here. Steel pipe will extend from here, and which will make the red color something. Okay, well. And for last one for the chapter 6 in the conclusion. And the modified annulling furnace model show is very well mixed uniform flow than the basic model because it's due to the swirl flow and the down flow by the upward buoyancy flow. And the second one, the flow field behavior and the temperature distribution in this study coincide well with those of the published paper by the Hand et al., who performed the study on the rotational flow of the fan. Moreover, the temperature difference by using modified model in the recent study have the more uniform than those of by the Reeler et al. They performed the bundle still by around 50 degrees Celsius, but in the recent study only 13 degrees. So it's more better than the real add-on. And the last one for the pertinent, by select the pertinent position of the steel pipe arrangement at the Reynolds number at 24,000 with the horizontal spacing divided by the diameter at the 3.13 and the vertical spacing is ratio with the diameter, the steel diameter and 1.56, and then we can obtain the lowest temperature difference value of 9 degrees. This is the main objective in the recent study. Okay, thank you for your attention.
Good morning, everyone. I, Renu Dalal, PhD scholar in Ambedkar Institute of Advanced Communication Technologies and Research in CSC department. Today, I am going to present my PowerPoint presentation on empirical analysis of routing protocols in opportunistic network. And my paper ID is 25. These are my table of contents. First, I will give introduction of opportunistic network. Then I will explain the applications of opportunistic network. After this, I will discuss some challenges for opportunistic network. In related work, I will explain some routing protocols which are belongs to opportunistic network. After this, these routing protocols are simulated on one tool. One tool is known as Opportunistic Network Environment Tool. It is open source and Java based. After this, results and analysis are discussed and I will come upon the conclusion and future work. So, this is the introduction of opportunistic network. After the great advancement of wireless technologies and mobile network, a new approach is introduced which is known as opportunistic network. It is based on the principle of store, carry, and forward phenomenon, which is used to transfer the messages in opportunistic network, and it is called as delay tolerant network. Routing in messages in delay tolerant network are such a big challenge because of its characteristics: high level of mobility of mobile nodes, and there is no end-to-end connection from source to receiver node. It having no fixed infrastructure for nodes while transferring of messages from end to end. In sparse network scenario, integration of heterogeneous devices in which nodes having different capacity and type can be communicated through opportunistic network. Opportunistic network and traditional network both are different from each other, but they having also some similarities. In traditional routing, before data forwarding, end-to-end path must be established. But in opportunistic network, there are heterogeneous devices or network nodes which are not directly employed. First, they invited to join as seed node, and this seed node become a helper node. After performing a task, seed opportunistic network grows into an extended opportunistic network by merging helpers node in network. Figure 1 shows opportunistic network. It includes 6 pitchers or 6 heterogeneous nodes, and arrow symbol shows the movability of object, and another symbol shows the opportunity to communicate. So, whenever these heterogeneous devices having opportunity to communicate according to their spectrum range, they can receive and transfer the messages from source to receiver. These are the some applications of opportunistic network. First, we can use opportunistic network in wildlife monitoring. We can monitor the animal's life by using the sensor nodes. Other applications, we can use the delay tolerant network in rural villages or remote area to provide communications. In emergency and military operations, we can also use the delay tolerant network. Other applications of opportunistic network are recommender system and mobile data offloading. These are some challenges to provide routing in opportunistic network. There is no any secure communication from source to destination. It it not use any centralized environment. Disconnected or intermittent connectivity environment is there to provide routing in opportunistic network. Very frequent and disruptions delay while providing the communication or transfer the messages from source to destination. Other challenges are energy efficiency of mobile nodes, functionality issue, buffer capacity, protracted delay, security issue. Now, the related work. Various effective routing protocols are proposed in mobile ad hoc network. Due to its low cost of development, like hybrid group key management for heterogeneous network and other routing protocol. But routing in opportunistic network are work in different way. Mobile load in opportunistic network having no fixed path, no source to destination connectivity between node, and high movability property of nodes makes network recurrent. Opportunistic network work in real time scenario with diverse number of applications like underwater sensor network, SynWids, shared wireless info station model, ZebraNet, and so on. In opportunistic network, I will explain four routing protocol. First is direct delivery, then epidemic, then spray and wait, and last cluster protocol. In direct delivery routing protocol, here sender node keeps the messages himself until he didn't find the direct contact to receiver node. It comes into picture in 2004. Any message is not disseminated to any nearest mobile node. Only due to direct contact of message deliver node to message receiver node, this routing protocol is adequate in terms of network bandwidth and network resources. In direct delivery protocol, receiver node receives the packet after long delay so that sender node saves the packet in his buffer, which reduces the reliability of protocol. Epidemic Protocol is introduced in 2000. This protocol broadcasts the packet to its all neighboring node. Whenever the mobile node received the packet is disseminated until the destination mobile node didn't receive the packet or packet is not reached to its highest number of hops. Main objective of epidemic protocol is to reduce the delay and increase the message delivery. Consumption of bandwidth and memory is very low during transmission of message from sender to receiver. Now, the third protocol is spray and wait. This protocol comes into picture in 2005. An efficient and advanced version of epidemic routing protocol is known as spray and wait. This protocol works in two phases, spray phase and wait phase. In first phase, n number of message packets are disseminated by sender node to n number of mobile nodes in network. These n number of nodes who received the message keeps the message packet in their buffer. In second phase, mobile node carry the message with itself till he didn't find the destination node in his communication range. Last protocol is cluster protocol. It is introduced in 2010. Multiple mobile node with having the same mobility pattern and property forms the cluster in wireless network. To balance the load and minimize the overhead of network, this routing protocol interchanges and share the resources. This protocol achieves high scalability, packet delivery ratio, and performance, also having small buffer size. This protocol is suitable for only one hop and it having low latency with limited resource consumption. After the related work, I will come into the next section, result and analysis. As I told you before, I used one tool. One is Opportunistic Network Environment tool. It is used map route moment mobility model to simulating these four routing protocols on one simulation tool. Here, as shown in this table, I used one tool. Mobility model is a map route moment model, 5 megabyte buffer size, 4500 by 3000 meter square communication area, 1 to 12 hour as a simulation time, 1 to 3 meter per second speed of node, and 125 number of nodes are used while simulating these routing protocols. These are the four routing protocols and factors which shown in this table. On different simulation time, different message delivery, overhead ratio, and buffer average are calculated by this model. This is again the different simulation time is used and according to that different message delivery, packets, overhead ratio and buffer average time is produced by one tool. This is the graph which shows the buffer average time and according to simulation time it produces the result for different cluster, for cluster protocol, direct delivery protocol, spray and wait protocol and epidemic protocol. Here blue color is used for cluster protocol, red color is used for direct delivery protocol, yellow color is used for spray and wait protocol, and green color is used for epidemic protocol. Here, the maximum buffer average time in second and simulation time is in hours. Direct delivery protocol gives the maximum buffer time average, and cluster protocol produces minimum buffer time average. This is the graph between message delivered and simulation time. Here, here the message delivered packets are produced by one tool different simulation time. Cluster protocols gives maximum message delivered, and epidemic protocol gives minimum message delivered. But as compared to epidemic protocol, direct delivery protocols performs better in terms of message delivered. Here, the overhead ratio parameter is simulated according to simulation time. Here, cluster protocol gives maximum overhead ratio and direct delivery gives the minimum overhead ratio. So, here we comes on the conclusion and future work. Store carry and forward mechanism is used by the relay node or intermediate node for transferring the message to final destination node in opportunistic network. The aim of this paper is to analysis of some routing protocols of opportunistic network, measured challenges, and some important application were also summarized in this research paper. Different simulation is used to simulate the four routing protocols: epidemic, spray and wait, direct delivery, and cluster protocol. In future, our aim to design the novel routing protocol with minimum delivery delay and very low overhead ratio. Thank you all. These are the references. Thank you. Have a nice day.
Hello, this presentation is titled Applications of Virtual Reality in a Learning Environment. This is a review paper. This is the table of content for the various subparts that are covered in this presentation. Virtual learning environments can be defined as spaces that are designed to educate the students remotely via various online platforms. Virtual reality technologies are possible to be used in combination with the cloud gaming technologies to give rise to various virtual learning environments. These virtual learning environments can be used very effectively to create various cloud-based social virtual environments, which can then be used for various purposes, such as multiplayer virtual gaming or platforms for remote learning for various users. Virtual reality affects our perceived information with its various simulations, which are primarily gained through the senses of sight and sound. In this review paper, we mainly focus on an overview of a given cloud-based virtual learning environment. We study the application of the virtual learning environment in a cloud-based setting in an effort to find the challenges faced in the virtual learning environment creation process and simultaneously learn about the various possible existing and theoretical solutions for the problems faced. Virtual learning environments can be defined as the zones that are made to teach understudies or the students remotely using the various online projects or platforms. A virtual learning environment is simply a set of teaching and learning tools. It is designed to enhance a student's learning experience through the usage of various computers and the internet in the learning process. The principal components of a virtual learning environment package include curriculum mapping, which is the breaking of curriculum into sections that can be assigned and assessed, along with student tracking and online support for both teacher and students. Electronic communication also plays a major role in the impact of a virtual learning environment. Electronic communication generally includes email, threaded discussions, chatting platforms, web publishing, etc. The virtual learning environment can also include internet links to outside curriculum resources. These resources can be used to further impact the students' knowledge towards the topics being discussed in the virtual learning environment. This helps them gain an overall comprehensive increase in their understanding of the topics. Generally, it is seen that virtual learning environment users are assigned either a teacher ID or a student ID. The teachers can observe everything a student accesses in the virtual learning environment. Along with that, the student also has some rights towards accessing various shared contents. But the teacher is provided additional user rights that can help them to create or modify the curriculum content and track the student performance at any time so that they can design the optimal method to guide the students in the virtual learning environment. Virtual learning environments provide a lot of benefits for both students and the teachers. For students, the virtual learning environment allows them to benefit from a self-paced learning and the opportunity to learn new skills without having to travel very far or arrange specialized courses from various experts. Through the use of a virtual learning environment, the students also obtain a real sense of achievement that they can only gain by having the achievement purpose of doing something in a practical way. The benefits for the teachers in the virtual learning environment are equally huge. The virtual learning environments provides the teachers a highly freedom-based environment in which they can set lessons or the training courses for their students to complete all at once, no matter how far apart they are situated in real life. This allows the teachers to work remotely in a time of their choosing. A blended learning approach can also help them to keep their students more engaged with the course, spending some time working on practical tasks and some learning the theory behind what they are doing via a virtual learning environment. The cloud computing technology assists the virtual learning environment with giving a gaming backend as a service highlight that assists with improving the constant gaming performance needed in the virtual learning environment. Along with this, cloud computing models can also help with the issues of computational offloading that are necessary to maintain the latency and the improved performance of the virtual learning environment. Virtual learning environment can often offer feasible effectiveness with the application of additional technology that reduces latency and provides improved data for the virtual learning environment. It also includes the various immersive situations and the optimization of the video transmission provided with the virtual learning environment. The combination of virtual learning environment and the cloud-based gaming technologies can be used to design virtual learning environments that can be accessed remotely by both students and the instructors, which would enable them to gain a classroom-based experience which is extensively comparable to the real-life situations. In the current situation of virtual learning environment, the students enter these situations as symbols utilizing an organized PC and associate with one another with content talk, voice visit, and the control of shared items. As of now, virtual learning environment utilizes the main technology of multimedia for their purposes, such as recordings and PowerPoint introductions, to help in the correspondence of instructive ideas. However, the problem arises due to the absence of an intuitive situation with the training content. This makes an inadequate situation for the explanation of the different questions that may be produced during the study sessions in the virtual learning environment. These issues can be successfully evaded when using virtual reality in the combination with the virtual learning environment. The game engineers and the originators of today have gained huge measures and techniques of ground in the fields of virtual space or the condition structure. The ideal way of the teaching in virtual learning environment which uses virtual reality is through interaction and application. The students can gain a more hands-on and instructive experience with the VR, and the teacher can provide the exposure to this type of active learning each and every day. This can all be done within the comforts of a proper classroom. The main benefit towards using virtual reality is that it allows the users to become the avatar or the characters that interact in the virtual reality rather than just controlling them via a keyboard or a mouse. This pushes the realism and the experience to a whole new level and gives the VR technology its own unique charm. The virtual reality used in the virtual learning environment allows the students to give and take the benefit of the opportunity to explore freely. When the virtual reality tools were first invented, it was pretty much assured that they will be used in a classroom based situation to enable various students to gain practical knowledge while learning the theory. This technology is surely beneficial to be used in the virtual learning environments. One of the main benefits to virtual reality is the concept realism that it pursues. In the recent times, this concept of high realism has started to shape up very nicely in the application of virtual reality. This has subsequently opened up a whole new avenue for wide variety of applications for the virtual reality. Since its conception, virtual reality has always sought maximum realism to make it easier for the user to adapt to the virtual world. It mainly enables the virtual users to replace the world of our reality with the simulated sensations in the virtual world. This simulated perception of the virtual world helps us to gain new experiences and information easily, hence its need for extremely high realism. To be exact, the supposedly being an exact and objective replica of reality is regarded amongst everyone as having an extremely high scientific value. The main focus driving this review paper is to analyze the feasibility and the effectiveness of producing such a virtual reality learning environment, and if it can be successfully achieved with reduced latency and data speed requirements through the use of the current technology available to us. Many of the past experiments that have been done on virtual learning environment have shown us some compelling results that prove the increase in comprehensive ability of the various users that use this technology. This also proves computer-generated realities or the virtual reality can make it possible to provide enormous amounts of potential for all the users for various advancement in the technologies and general abilities through vivid simulations that are mostly comparable to various real life situations, and the effectiveness increases with the increase in the highly effective realism. The proposed architecture for virtual reality learning environment given here is designed with the information collected from various research papers that pertain to this topic. This proposed architecture is designed such that it can enable sharing of the educational content in the form of various multimedia technologies such as image, text, or video. All this can be done using the virtual reality learning environment. To achieve the actual application of this architecture given for the proposed virtual learning reality environment, there are certain technologies that are available today which can be used to satisfy the bare minimum requirements that are needed to achieve satisfactory results. The technology currently being used in tandem to design such virtual reality learning environment in this proposed architecture include high fidelity HTML, CSS, React Redux, and cloud gaming models. This is the architecture of the proposed virtual learning environment. In this architecture, it is very easily seen that the architecture is designed in four different parts. Three of them pertain to the users of the virtual reality learning environment, and the fourth part pertains to the virtual reality learning environment cloud node server. The virtual reality learning environment cloud node server incorporates various different parts which are needed for its proper functioning and the proper flow of the virtual reality learning environment. These parts include flexible curriculum control, visualization interface, virtual scene control, high fidelity rendering, state control for lessons and games. All these parts of the virtual reality learning environment cloud node server is designed with the combination of high fidelity and cloud based gaming models. Coming back to the three parts denoting the users of the virtual reality learning environment. In the bottom left corner, the part refers to the online instructor, and the other two pertain to the online students. These are the interfaces designed for the online instructors and the online student respectively. They are mainly designed with the use of high fidelity and HTML, CSS, React Redux. The interface for the online instructor enables the online instructor to gather all the necessary material they want to post on the virtual reality learning environment and send it to the Cloud Node server. Similarly, the online students can use their interface to download or access these materials from the virtual reality learning environment Cloud Node server. The use of high fidelity enables the virtual reality learning environment to incorporate many useful features such as high amount of parallel users, high competency in the creation of virtual 3D avatars, and well-designed, spatialized, immersive experience. High fidelity also promotes amongst the users decentralization and freedom for content creation and control its distribution. This also enables them to control with whom they want to share the content. Server-side resource requirement for the high fidelity is very high, and this requirement is also directly proportional to the increased functionality and performance provided by it. Use of HTML, CSS, React Redux is a popular choice for the creation of web platforms to hold instructional web pages. It enables the creation and access of convenient and intuitive classrooms, even through remote situations. The platform allows for lessons to be easily added and changed by the instructors more efficiently than other equivalents. Due to the high strain of producing simulated reality, it sometimes hinders the smooth information transfer between virtual reality learning environment and the web platform. Cloud gaming platform runs game logic that is responsible for the game mechanics and the game interactions received from the game server API, from the game instances, and the graphic processing unit renderer that creates the game world scenes in real time. The generated graphical information after encoding and compression are streamed to mobile devices, which handles the decoding and output to a game player. Usage of cloud to enable data transfer implies that large amount of resources need to be assigned for the proper rendition of the graphic processing unit created game world in real time along with high speed data link that is needed for the real time transfer. In conclusion, we can define various points. Virtual reality learning environment builds upon a wide number of existing foundations to provide a virtualized environment which is extremely suitable for social activities online and is also being at the same time very enjoyable by giving real-time interaction experience to remote areas through this platform. Even if the current technologies are lacking in bringing out the full potential of the virtual reality, the future possible applications of virtual reality learning environment include a wide amount of social, academic, or even possibly strategic level applications. Future applications may also lead to a full immersion virtual dive environment created through the combination of brain computing interfaces and virtual reality learning environment, completely controlled by the neural activity without the impact on the other senses.
So the first one, before they present our topics on behalf of our research group, my name is Ron Pandong. I would like to thank the editor of Rise 2020 and topic the content-based aging strategy for the ubiquitous healthcare application in the wideband wireless body area network. As my name is Dr. Đoàn Văn Dong from the Faculty of Electrical and Electronic Engineering, Opportunistic of University of Danfoss in Vietnam. In this presentation, it includes the five sessions. The first one I introduce about the motivation and the problem, and how the content-centric networking CCN work will be presented in section 2, and system model and proposal strategy will be presented in section 3, and performance evaluation, the result in the section 4, and finally we conclusion as well as the future work in the section 5. An introduction in the motivation of our paper. The first one is the internet communication model, like tradition, or another one is the traditional model, like nowadays, is the hot-to-hot communication. So that leads to the two problems. The first one is a limited resource setting problem. Currently, internet are distributed from a source to server, many server sample setting from producer like web, like IPTV, Internet Protocol television, setting from user like the YouTube, Facebook, and so on. And the second problem is here, that is the file transfer problem. When the large number of the file transfer at the same time send requests and ask the data from the server, that leads to the offloading server. That is to say, the server cannot afford the request data from the many users, many players. And another few, the user and application just care about what you see, and they don't care about from who and from where. So hot-based communication, like traditional communication, is all this. And internet traffic already content-oriented, like CCN, like data center, like the web page, multimedia, peer-to-peer, and IPTV, and related to the cost deployment and storage cost. It's either getting cheaper sharply compared to the network cost. So based on this point, it needs to change the current internet to a new model, to a new architecture, to effectively support the land distribution and energy policy. So CCN is the best choice to satisfy the requirement. And related to the objective, from the problem we have to objective, that's the effective content distribution and how to choose to maximize the probability of the content sharing to user from the lyrics, the text of the note. And the second one that is also important thing related to the network paging of the CCN, that is the smart paging policy, and how to store the most valid content in the case of the nodes. And to address the problem based on the content-centric networking. And in this section, I will introduce how CCN works. And what is CCN? CCN is the name content get data by name instead of the putting data to specific location like the IP base. And in the IP base, you can see when we want to access the website, it needs to resolution to the IP, right? And different ways in CCN network, it directly access by name. And CCN also use the network paging. Of course, I have a talk of is able to use the content for many times, and CCN based on the use for many times. So it well support for mobility. So you can see in the figure, once, this is the sample. If one, you can see this is the many browser like nodes. And we have one server and 3 clients. When client 1 needs to the information, example, the video, they ask the lyric notes like note 8. Note 8 asks, I don't have, I ask to the lyrics. Note D. D asks B. B asks A. Of course, I don't have. A don't have. I ask the server. And server, of course, example server say the whole data. They reply feedback to the Epic nodes based on the request pass, and the different way the important in the end every node when receive the content they store it is indicates the storage like the I you will see and reply to the client 1. Another time when client 2 or another client want the same content, they also add the neighbor nodes like those I and those I request. Of course, if they have the same the content before, and they don't add to any one, they just reply because they have this. They have the content in the store. They just reply very quickly to the client one. We are those I. So this is the CCN work, the scheme. And so the advantage of the CCN, we have 4 points. The first one is to maximize the probability of the content sharing and reduce the bandwidth use, and reduce the data time, and enhance the quality of the service. So these are very important thing of the CCN. So based on the advantage of the CCN, we apply to the wallet model anywhere network. When apply the CCN in wallet body and network, we have some problem. The first one is the caching problem. The caching problem is the existing caching scheme, so the low utilization efficiency of the those store content due to stringent decline of sensory information in the wireless body area network. And so the low energy of the sensor nodes, because every node has a small battery inside, it's so very low energy. So how to address the problem? That's our objective. And how to choose the best caching policy to with the efficient for the CCN wideband model, and how to give out the system to get the valid content in the nodes. And you can see this is our model. In the left side, we It's the intra body communication and another is the intra communication. And in the inside the intra body communication, we have the pattern. Pattern can moving, and of course the lie on the bed and moving around. And every sensor node equipped on all the implements inside the skin. They collect the data from the environment. And we have see the in the model we have the one coordinator device. They collect the own information from the sensor to send out to the body communication. And in this example, we using the router and the final is the medical server or physician doctor, then using the data content to treat the patient. This is the CCN wideband network model. And based on the problem and objective, we propose the scheme based on two aspects. The first one is casing decision, and the second one is replacement policy. And related to casing decision, the casing decision will be implanted in each of data item by considering the important attribute. Like the first one we consider in the data freshness. This is very peculiar for the wireless body error network. This is important because it maybe change very quickly. And the second metric is the sensing data, and the third one is popularity of the content, and the hop count, and the last one is energy of the nodes, because every node have a small battery to retain. And how to combine the metric to calculator for retaining the most valuable information indicate for the server time. And replacement policy, how to give a replacement policy. Nowadays it use some policies such as the first in first out, such as the LRU, and using the probability also to replacement. And in this replacement, we compare happens between the candidate data item and the storage content when the KE full. Because when the KE full, we need to replace the invalid content. So the candidate data item is retained today if its valid is larger than any value of the storage content. So the result of our scheme in the CCN wideband model. The first one we evaluate two metrics. The first one is K-hit ratio. The second one is the delay or data delay to trigger time. And what is the casing hitting rate? The casing hitting ratio or casing hitting, the two names is the same meaning. The casing hit ratio is the probability to achieve a K hit from the storage content of the node instead of the original server. And the K hit ratio over time, you can see in the figure, increase over time. For the old scheme, we have 1, 2, 3, 4. The first one is the own way, first in, first out, own way, LRU, and probability LRU, and our scheme coded content base. And you can see the hitting rate 0 is great in the modulation time is 2000. And under same, we can see another fuse, another spec is under the same LRU replacement policy. We can see the first, second, and third probability caching always perform better than always FIFO and always LRU. And the caching hitting ratio of the proposal content in the blue color approach is significantly increasing in time and outperform all the schemes. This is very good of the hitting hit ratio. And the second metric we perform and evaluate uh, to focus on the delay metric. And delay metric, of course, we can see the data retrieval delay. Data Data retrieval delay is the compute from the time when the consumer send the internet message to the reception of the matching data. And propose, so we can see in the figure, the proposed achieve lowest retrieval in compared with the order. And our proposal scheme just yes 0.02 second in average data retrieval delay time, lower than other scheme. So lower, that is mean the user can get the data very quick. That's it mean the intermediate node can storage can take the content, the data in the storage very useful, and the delay time respect the ability fit fetch data from intermediate node. So that is very efficiency of our perform of our proposal uh, approach. So finally, the conclusion. So in the proposal approach, utilize the content-based techniques to retain the most valuable content in the key, or retain the valid data in the storage, and to increase the key decision efficiency. And you can see in the two figure, the numbers result focus on the hitting ratio and the delay time has shown the remarkable effectiveness of the proposal approach in terms of improving total hit rate and reducing data retrieval delay. So it's a very useful to apply the our proposal approach related to the taking decision and replacement policy in the C content-centric networking wireless body area network. That's all. Thank you for your listening. Once again, thank you for our colleagues as well as the editor of the Vice 2020 for your help to complete our paper on the conference that was on your Zoom. Thank you.
Firstly, I thank the organizing committee for giving me an opportunity to come to this conference and present my work concerning ambiguity design using the logic method for the PV system architecture setting condition. My name is Nosi. I study at Chungyang System University in Taiwan. Uh, Now I present my report. Uh, the outline of this report is constructed as follow part 1 introduction, part 2 solar energy for the standalone panel system, part 3 ambiguity control of the standalone solar energy system, part 4 simulation result, and the end conclusion. In this slide, I will show the part one. Under uniform illuminant traditional methods such as P&O, IC, and so on. It's easy uh, uh, to, to get the MVP before they has one with on the PV curve. We can see from the one under uniform illuminance is one bit is generated here, but under factor setting effect, uh, many bit reactors here. Traditional methods such as P&O, IC is uh, uh, will fall into the local MEP. Therefore, the Gaussian energy loss and reduce solar conversion efficiency. Therefore, many methods have been proposed such as particle swarm optimization, PXO, and gene algorithm, GA, and so on to find the local MPP. However, PSO is quite intensive to computing and take a long time. The GA is too complicated and the computation time is too long to find the local MPP. In fact, it's in fact it's by the living concept. There propose a new algorithm to find the local MVP. This is a hybrid method by combining the support flipping algorithm and the PSO method. The idea of this combining method is to use SFLA to packaging the logbook MVP and move to the P&O method to reduce the calculation manipulation in the MVP. I will show the standalone solar power system using in this paper. In this paper, we propose such a standalone module to efficiently use the solar energy system. This system includes solar panel, high-edge method, and a controller, and DC-DC boost converter, and DC load. When the solar energy panel receive the solar energy, they use the robot method and the controller to find the MPP and use the DC boost converter to transfer the power energy into the DC load. In this slide, I introduce the scale, the scale of uniform illuminance figure 3 show the PV curve uh, mm, of the temperature and irradiance variation uh, from picture 3 uh, illustrated the PV curve for several different uh, environmental conditions. Uh, when each working curve have maximum power. Therefore, control power controller is required to remove effects due to temperature and sunshine intensity to eject more electrical power from solar energy. We can see from the figure 3 when the temperature is fixed. When the temperature is fixed, the illuminant increase, the will get the power output increase. When the um, uh, illuminant is fixed, um, the output power is decreased when the temperature increase. We can see the line, the link line and the next line. Compare this. This slide is very important. It talk about partial setting effect. The figure 4 show the PV curve of the partial setting effect and figure temperature. We can see before the change, MBP before the change is 600.1 watt. After change, 3 fixed created. After MEP, it get the 336.9 watt. Another MEP as 200.1 watt and 167.4 watt in the local region. This is the two peaks fall into the local region here. From figure 4, we can see that when the solar panel is set it, they will change from the single maximum peak to multiple peaks. More sunshine change will reduce more speed. So in this slide is MPPT control of the standalone solar energy system. The basic diagram of the standalone macho boost converter is illustrated in the figure 5. The diagram has solar panel and the Arduino processing board, this IC TL494, and DC-DC boot converter, and a load. When this system operates Arduino processing board using uh, two signals, there are IPV and DPV. Compare with the voltage feedback from the DC load using IC TL494. The chain of D2 compare signal will change the duty ratio to control DC-DC boot converter. Advance of this circuit is easy easy in installation, is simple junction, and low cost and high performance to get local MPP. The Rufus hybrid method is a combination of LA and traditional P&O method. This hybrid method can effectively prevent the jet region. The hybrid method has two stages as follows. Stage 1, support for flipping algorithm at LA. We use the equation 5, 6, 7 to update value. This method is applied to find the lockable region. The stage 2 is the P&O method. P&O method is it's used to check the maximum power point accurately and adds content ingredient and temperature by changing the small voltage, the voltage and current value after changing measured by the and compare with the previous value by based on the result of the voltage and power change. Algorithm will decide to increase or decrease small amount voltage. When the first patient is finished, the hybrid method is finished. In this slide, I saw the simulation result here. The P&O, PSO, SSLA, and hybrid methods are simulated as shown in the figure 6, 7, 8, and 9. With the hybrid method, the SLA is used to find the optimization, optimal solution at the result. Here, the robot method is can successfully and quickly check the logbook MPP. This value uh, 3G 6.9 here is equal here. When compared with the PSO method, PSO method is get the local MPP here, but it use longer time than the SSLA. This method is quickly to get the local MPP. Uh, this paper is different from the traditional standalone system where the traditional MPP algorithm had been improved to overcome factor setting effect. The problem of the watching energy uh, due to by a check in the local MPP has been solved. First stage, the method use the SLA to find efficiency of the local region and then quickly find the MPP through the P&O method. This solution is effective to avoid falling into the local MPP and quickly achieve the best energy conversion efficiency. The P and O method is very easy to program. It's often used to check the MVP. Therefore, combining SLA and P&O is a useful solution to increase the energy conversion efficiency. Firstly, I can the Ministry of Science and Technology ROC on the red mode for supporting me to attend this conference. Uh, I also attend the organizing committee forcing me an opportunity to present my data in this conference. Thank you for your attention. For objective reason, I can present this online on Gmail. Please send to my address here. This is my address. Uh, Again, thank you for your attention.
Uh, okay, hello guys. So my name is Ting. So hope you guys stay well in that pandemic. So now I'm very proud to represent my team. So to talk about our study, which is fast estimation of building costs using machine learning. So our my presentation contain four parts. The first is introduction. The second is method. The third is result, and the final one is conclusion. So first for introduction, so if you guys, as you guys know that machine learning algorithms are able to self-learn based on the self-shared data. So it is becoming widely used in different technical sectors. It quickly and automatically produces models that can analyze the bigger and more complex data and deliver faster, more accurate results, even on a very large scale. So and by building precise models like that, an organization has a better chance of identifying profitable opportunities or avoiding the unknown risks. So among all of the algorithm of machine learning, right, for example, classification, recursion, informal learning, clustering, or dimensional reduction, the most outstanding method nowadays is regression, which is a method that we try to model and predict the output based on several input data. Uh, so, so, so mention about the predict model in the civil construction sector. Machine learning is mainly used to predict the price of buildings from the mortgage data of building features. So, for example, location, state, useful surface, garden. I mean, really useful location near the school or anything. So in a simplified representation, this one is the current workflow of buying command in a construction company. So at first, once a buying command is made, the key information on the features of the house to be built, such as the ground surface area, number of floor, number of windows, construction material are collected by the sales representative. So these data are then passed to the design team, right? So they will sketch a plan of the future house and structural mechanics. So this guy will assure that the design is safe to build, so then you will build. So the resources such as quantity of material and label needed to build the house are estimated. So which are then used to compute the final cost, right? So but there's a problem that this one such iteration that take a lot of time and requires many interfaces between different services within the company. So leading to the really complicated coordination work. So that's why they really wish to provide a fast and reasonable accurate estimation of house building costs to increase of the company. Oh, sorry. So in our study, we use machine learning. So machine learning is used to develop a tool in response to the above request. So it's aimed to build an estimation tool which can provide fast and useful estimation of house building costs. So as shown in here, here's a figure. So the machine learning, but it's workflow of a command in the house building company. So machine learning is expected to link the buyer request and final cost within the short term. So that interaction between salesperson and client can be improved and repeated intermediate design can be avoided. So in this presentation, we just try to consider the traditional machine learning regression methods such as linear regression. We try to find the best fit line based on the linear equation. Right. So next one is subprofessional machine. We try to find a function fx with most deviation from the margin from a target y, like this figure. Next one is the k nearest neighbor. Actually, this method is used in mostly in the clustering problem, but it is still possible for the regression problem, so we still use this. The below one is a decision tree. Actually, this method is create a binary tree for finding the best numerical feature to split the data. More tree mean more accuracy, mostly like that. So the last is also an elastic net because so okay. So but I mean nowadays we still have some really good regression method, which is the boosting method, like gradient boosting, and boosting almost used method nowadays. EcoBoost, the extreme gradient boosting, or even they use artificial intelligence, artificial neural network is still okay, but we will consider it in our future study. Now going to our data preprocessing. X and Z. X is 11 features, Z is Z1 and Z2, which are the cost or and the maintenance cost. So here is a statistical data distribution. So as you can see here, the data is quite normally distributed, but some data have right and left skew, but it's not that much, so we don't need to skew back the data. It's not affect much. Actually, it's still okay if we skew back. So below is numeric distribution of features. So it is easy to see that the data is not in the same range, especially x1 very small compared with the rest. So we have to normalize the data. We normalize by the equation x normalized equal to the x actual minus x mean divided for x max minus x mean, which we normalize data. So in the right is the heat map and the correlation matrix of all feature. Um, this so from this figure, we conclude that there is no autocorrelation deflection in this data set, so we not care about that. So here's our regression result of x and z. So as you can see, the accuracy we assume is the r squared multiplied 100. So as you can see, the linear regression with the accuracy of z1 is 95, z2 is 94, z1 plus z2 is 94, leading the first rank among the other methods. For the computing time, it is still it also linear regression is also the fastest computing time for this one. Yeah, this number in the table. For support vector machine, it's a really high accuracy for Z1 but lower for Z2 and Z1 plus Z2, and also so really low slow computing time. 3.5 for Z1, 3.2 for Z2, and 3.8 for additional Z1 and Z2. So so this slide we saw the comparison between the predicted and actual results. So can easily observe that the line fit very well the data, but it is still show some spreading of actual Z1, Z2, Z1 plus Z2 here because of the not really high accuracy. If it is 98 or 99%, you can see it's very fit. That red one. So the right is the difference between the actual and the prediction result using linear regression. So as you can see, the maximum error is 4% around that. So based on the theory that a partial derivative which has the highest absolute value is the most important parameter. So in this line, we're trying to finding the most important x based on the partial derivative that. So it means a larger partial derivative indicates that a small change in the feature will lead to a significant change in the output. So it's listed here in the table. For Z1, you can see x1 and x7 and x9 leading most important feature with the positive slope coefficient. For Z2 and Z1 plus Z2, x2 for x7, x8 and x9 leading the most important feature. So because of those important features, we want to see what different if we not consider it in our model. So this table shows the result without the x2, x7, x8, x9 or all of them. If we not consider them, what happened? Something like that. So as you can see in the case of x2, it is reduced like 3.5%, and if whereas in the on this one is missing, it reduced can 8.7%, pretty much. So okay, so the first one is the actual task. So we want to do also the the inverse task. So in our study, the reverse regression case is performing this study to extract more insight of the data. It shows the relationship between the feature and the corresponding target, but also the relationship between the target guaranteeing thereby a better representation or interpretability of the predicting how Turing code problem, right? So thus it become a multiple output regression with only one dependent y, and the output is 11 feature. So these specific input were considered including Z1, Z2, and the Z1 plus Z2. The artificial neural network model is implemented in this case is a figure. So basically, the ANN model consists of 3 layers, 1, 2, 3. Come up with the 5 and 7 layer in the second and third layer, the second third one. So we use the ReLU activation function and also the Adam optimizer, of course, used in the reverse regression problem. So here below is the loads of the model for the 3 cases. you can see it is loss and chain and test is really fit in each other. So it's good. So this table listed the minimum value of that uh, and the associated input variable. That one, that true, that one, that's true. So actually, in practice, this information would help the salesperson to set the limit of the minimum price that assures the profit and the associated features that the buyer can have with this minimum cost. Okay, so for example, but this result is a conditional expectation. You can see the distribution. It is not that much. So here, for example, H3, in this case 20, 18 and 19, for example, X7, 1.8, 1.9, I mean, it's really distributed to each other because it is a conditional expectation result. So the final result we perform is we want to evaluation of the data distribution. So in this section, the value of the output feature, that one plus Z2 data is varied to understand the associated trace of the input value X. So 5 values, 100%, 80%, 60%, 40%, and 20% are used to compare with the maximum value of Z1, Z2. So maximum value is of the actual term is 2100. So in practice, actually, this one in practice is really important because this information would help the salesperson to quickly guide the buyer about the best feature that he can have for a given budget. So, for example, um, uh, the salesperson said with this 1,060, 680 million dollars, you can get this feature. Yeah, stuff like that. So okay, for the conclusion and future study, see it is on our result. So for the conclusion, we say in our study we comparing between several traditional regression method framework in machine learning, right? So finally the result show that the linear regression show the highest performance based on its R square and also the corresponding computing time. So also we perform the inverse regression problem to look more insight into the data. So for the future study, we will perform the multiple output regression using deep learning and modern regression method. For example, gradient boosting, come up with the realistic meaning of each model. So the problem with the intermediate output suggested label codes will be also considered. And final is the optimization the price code with constraint when we perform using deep learning. So thank you guys for listening.
Hello everyone. In this presentation, we would like to talk about generative adversarial networks for black hole image generation with highly limited sample set. As you know, the capture of the black hole image is the dream of scientists from several decades. But only from last year, this dream became feasible. So the scientists use even horizon telescope networks coupled with very long baseline interferometry methods, and after that apply some sorting and fusing data processing in order to get the first image of the black hole for the supermassive black hole at the center of the galaxy M87. So the objective of this study is try to reproduce the black hole image by using the brain. The brain is the combination of two neural networks. The first one is the generator network, try to learn the distribution of the sample data. And the second one is the discriminator network, try to get the output from the first network and use the target data, try to apply the fine-tuning process in order to adjust some parameter in the network. So in order to apply these methods to reconstruct the black hole image, we develop a database of the image acquired from the internet and we apply some data augmentation techniques in order to enhance the database. We use two RAN models. The first one is the Wasserstein RAN. For this method, we use the Wasserstein distance. And you can see here the evolution of this distance during the training process. And we can observe that the conversions is very quick. And now we can see the results on the reconstructed image. For example, here, during some iteration, we can observe the black hole silhouette occur, but the quality is not good at all. The second models we test is the deep convolutional RAN. Normally, this convolutional operation is dedicated for image processing. So, for example, here we can observe that the conversions is very quick, and the training times is 30% faster than the Wasserstein RAN models. And here, this graph shows you to the evolution of the loss for the first network and the second network during the training process. And you can see that conversions is very quick. When you see on the reconstructed images with these models, we get better results. For example, here at the final iteration, you can observe the silhouette of the black hole. And finally, when we compute the probabilities for the difference between the generated image and the target, we reach a level of the accuracy about 0.5 to 0.6. It's not very good because we have very limited sample set. So in this study, we show that the RAN models is able to reconstruct the black hole image, but we need more data to enhance the training process to get very more accurate results. So thanks for your attention.
Hello everyone, my name is Nguyễn Quang Sát. Today I present a paper that accepted in the conference July 2020 with the number of the paper 137, and the title of the paper is the Summary Optimizations for Automotive Distributed Space-Time Coding Cooperative Communications. And now I will show the slide and my presentations. My presentation including 4 sessions. The first session is introductions, the second session is system model, the third session is simulation results, and the final session is conclusions. In the introduction, we introduce the bidirectional relay communications. In the bidirectional relay communication, which is also named two-way relay communications or analog network coding, the source and the destinations both have their own data and send each other with the help of the one or several relays. Recently, more and more research work has focused on finding optimal capacity regions for the two-way relay networks. In our correspondence, we maximize the total sum rate of the two-way relay network and laying automotive space-time coding scheme under the constraints of the consumed power at the relay. Specifically, with a predetermined value of the sum rate of each direction of the bidirectional cooperative communication network, the total power consumed at the relays and minimized to meet their sum rate constraints. Next, we go to the second session in the system model. The source and destination need to exchange data with the edge of the two relays, the automotive distributed space-time coding scheme and the physical network coding are employed in these networks.
In this network, we see that the source S and the destination want to exchange the data together with the half of the multiple relays in a mirror. So we will have two time slots. The first time slot, the source and destination, will transmit the data through this relays, and the second session, the relay will forward the data of the destination to the source and forward the message of the source to the destination. The XR1, XR2, R2D, or R1D are the channel parameters for the channel from S to relay number 1, from S to relay number 2, and from relay number 2 to destination, and from relay number 1 to destination. So the signal transmission in this system model include two time slots for the source and the destination to transmit their crossword to each other. In the first time slot, both source S and destination send each signal reverse-story to the relays. There are two expressions for the two crossword from source expressed to the transmission. In the second slot, the two relay amplify and forward their receive signal in asymptotic distributed scheme to the both source and destinations. We assume that the maximum of the total allocated transmitted power of the two relays is equal to 2 SPR, and the minimum of transmit power of each relay is established at the special value. And here is the system rate of the out scheme in estimate R equal to 1 over locus of 1 plus S and R at the destination 1 and destination 2. And the goal of this paper for is the optimization combustions. The goal is actually maximize the total sum price of the BBC scheme, but also to ensure the one-way sum price components to be greater than predetermined value. The formula for my optimization problems. And the next simulation, we move to the simulation results. In this figure, we can see that the optimized BBC protocol provide much higher algorithm price in comparison to the FAF OCC.
Good morning all. I'm Dr. Tawhid Sultana, Professor in EC Department, co-author of the paper, A Machine Learning Approach for Detection of Depression in Tweets Using Sentiment Analysis. Today I'm going to present this paper. Statistical data by WHO reveals that depression is a major cause for many of these social disadvantage. Patients with depression do use the modern day social networking to express their emotion. Selective analysis of social networking data will result in determining the degree of depression and solutions for the psychiatric effects. Depression on social media are becoming an integral part of people's life. They reflect the user's personal life. People like to share their day-to-day activities, happiness, joy, and sadness on social media. These platforms are being used by the researchers to collect a lot of data and do some meaningful research on the data. In this paper, a machine learning based model has been proposed for sentiment analysis from social networking data. The proposed model uses support vector machine, decision tree classifier, and Bayes classifier. The performance analysis of the proposed model was evaluated by Python simulation with the aid of count vectorizer, and decision tree classifier. The proposed system is in machine learning. There are many sentiment analysis such as decision-based system, Bayesian classifiers, support vector machine, neural networks, and sample-based methods. We have used decision tree classifier, SVM, and name-based classifier. We decided to use these three for running the model. The model is written in Python and it will tell whether a given tweet is depressed or not. This flowchart shows the model to detect the depression in tweets. So we are using the machine language created for sentiment analysis using decision tree classifier, SVM, and name-based classifier. The model created is written in Python. The model tests the tweet. If it is depressed tweets, the count is recorded using the count vectorizer and decision tree classifier. And if it is not depressed tweet, then the count is recorded again using the count vectorizer and decision tree classifier. The above flowchart, that is the model, is done in two parts. In part 1, we have used the count vectorizer and decision tree classifier. Then in part 2, we have used the TF-IDF for tokenization, and as in the part 1, the decision tree classifier is used in part 2 as well, along with two more classifiers which are support vector machines and name-based classifier. This shows the comparison of the positive and negative sentiments for both part 1 and part 2 of the model. Two different word clouds are made. One is from positive tweets and the other one is from the negative tweets. The positive tweets are shown by red and the negative tweets are shown in blue. We can notice that we have done tokenization, stemming, converting the text to lowercase identification of stop words manually in case of part 2. So it is evident from the word cloud that the word depression is now taken as depress, and it is the case with many other words also. So part 2 is best compared to that of the part 1 model. See, the accuracy of the model 1 was tested and it was really impressive. That is, it was 99.6%. But from the data analyzed below, we noticed that even though the accuracy was 99.6%, this model was not able to predict the second tweet properly. So we have gone to the part 2 model. See, you can see here in the results, the accuracy score for decision trees classified is 99.6, and for SVM classifier it is 99.41, and for names classifier it is 92.7. Now this sheet shows the three different classifiers: decision tree, SVM, and names classifier. The parameters used are the precision, the recall, and the F1 score and support for all the three classifiers. So not depressed, depressed, micro average, weighted average, and confusion matrix for the three classifiers: decision tree classifier, SVM classifier, and names classifier is shown here. And this is the confusion matrix for decision, and this is for SVM classifier, and this is for names classifier. So we can conclude that as we have seen the decision tree classifier and SVM were able to predict the tweets correctly in part 2, whereas in name-based classifier was not able to predict the tweets correctly. Hence, we can say that decision tree classifier and SVM were best suited for this model. So these are the few references. Thank you.
Good afternoon. Myself, Nisha Sultana, doing MS from Mount Clair State University, New Jersey, USA. So I'm presenting a paper on network technologies around cloud computing. So cloud computing is one of the fastest growing areas in the contemporary technical world. It provides cost-effective, flexible, and reliable infrastructure for business and provides episode-limited agility in computational economy. When business data gets moved to cloud, it becomes more and more important for the networking risk it brings and creates a secure networking framework around it. So the main three market leaders of the cloud technology are Amazon, Google, and Microsoft. This paper focuses on major networking products offered by these three companies and provide an overview and comparison between them. Cloud computing as a type of main categories of cloud computing services: infrastructure as a service, platform as a service, software as a service. So this paper is focusing on networking service in IaaS. So this infrastructure as a service provides data center facilities, networking, servers, and storage. This slide shows the current adoption levels of IaaS, where you can see the AWS is having 68% of running apps, 15% of experimenting, and 7% of plan to use. Whereas Azure is having 58% of running apps, 22% of experimenting, and 8% of plans to use, followed by Google Cloud, IBM Cloud, VMware Cloud on AWS, Oracle, Alibaba. So this slide is showing the comparative studies for major networking product. So virtual networking for AWS is virtual private cloud, is safe for the Google Cloud, and Microsoft Azure is having virtual network as in virtual network. And domain name services for AWS is Amazon Root S3, Google Cloud it is domain name services, and the same for the Microsoft Azure. The comparative studies for the content delivery network, load balancing, and dedicated connectivity is also for all these three different clouds. Next, comparison between the Amazon VPC, Microsoft Azure, and Google Cloud VPC. There is classless interdomain routing is a set of Internet protocols standards that is used to create devices. So latency it is a 50 price market, highest market penetration and high satisfaction for Amazon VPC. So this is a comparison. So this comparison shows the latency for the DNS services of Microsoft Azure's DNS, Google Cloud, and then Amazon. So here the Microsoft Azure DNS is highest compared to different clouds DNS. Next comparison, the table for the market growth, where you can see the AWS comparison 2017-18 years, You can see here AWS is having annual growth of 46.3%, whereas Azure is having 75.9%, Google Cloud is having 81.7%. The highest is for Google Cloud. So coming to the conclusions, it is clear that the networking is unlikely to be the differentiating factor when it comes to choosing a cloud provider for most organizations. In this paper, we have compared the major networking features of top 3 providers and showcased the latest snapshot for engineers to refer a provider. The features around these technologies are changing every week, and an updated reference point will be helpful to baseline the service decision. So these are the references. Thank you. Thank you, one and all.